The second type of reaction is a hydrolysis reaction. In the hydrolysis reaction, I'm using water as a nucleophile. So in this type of reaction, water is going to be a nucleophile. So the medium that I'm going to be working with is going to be either a basic medium or an acidic medium. It depends on what you are using. You're using an acid or are using a base. The reaction is going to proceed by replacing all the leaving groups of the carboxylic acid over here. So all of these are going to be replaced by the OH of the water. So your product is going to be a carboxylic acid for all, except the ones that use basic medium, a strong basic medium. So for this one, for example, I'm using a strong basic medium, so I cannot get the acid. I'm going to get the base of the acid. This reaction is called saponification reaction, where you get the base of the acid. This is soap. So saponification is the reaction of esters with water in presence of a basic medium. So it's a hydrolysis in basic medium to get the base of the acid. So let's go ahead and start by an example of an acid chloride and react it with water. Always determine the medium that you are working with, because as I said, with hydrolysis, I can go with both mediums in there. And we're going to have an example on both mediums. So if I have water and I am using pyridine, I know that pyridine now is a base. So my medium is going to proceed by a basic medium. Basic medium means that the nucleophile is going to come and attack the carbon of the carbonyl in there. I'm not going to protonate the oxygen. I don't have an acid. So the base is going to come, attack the carbon of the carbonyl, form a negative charge on the oxygen in there. Remember that we have a good leaving group. So we can do resonance immediately and kick out that leaving group. And then any extra hydrogen in the solution in there, so this extra hydrogen here, that is going to be picked by any base in the reaction, and that is going to be a Cl minus. So in order to prevent the HCl from happening, the pyridine immediately jumps in, traps the HCl in there, and this is going to be your product in this case. You're going to get a carboxylic acid, and you are going to get the pyridinium chloride. Always your product is going to be an acid whenever you start with water as a nucleophile. This is an example of hydrolysis in basic medium. Let's do an example of hydrolysis of acid chlorides in acidic medium. So we're going to start with an acid chloride. So this is hydrolysis in acidic medium. Mechanism is going to be exactly the same as we already know in acidic medium. And there, so for the acidic conditions, you would need to have water. But now, clearly, the reaction mechanism is going to state that you're using an acid. So immediately, whenever you are using an acid, the first step is going to be the protonation of the oxygen. It's going to be the first step in the reaction. That is going to be always. Every time you have an acidic medium, you are going to protonate the oxygen of the carbonyl. So you look where your carbonyl is, where is your weak bond, and that is where you are going to protonate. So we protonate the carbonyl. Once we protonate the carbonyl in there, now we made that carbon very partial positive in there. So now we are ready for the nucleophile to attack. So now we're going to take the water and the water is gonna come and attack. Every time I make a bond, I break a bond and add the electrons to the oxygen. So we're gonna end up getting, this is going to be an O. Here you go, a hydrogen here. That is going to be a chlorine, and you have your water. Okay. So now after the addition of the water, I need to kick out the chlorine in there. To do this, I need to start from this oxygen, form a double bond, and the chlorine is going to leave. The chlorine, any extra hydrogens that I have in the reaction, I can simply get rid of those by the base which is in the solution. Because I do have over here, so here I'm going to have an oxygen and the hydrogen. See, I have here now two hydrogens that I want to get rid of because my final product is a carboxylic acid. Since I am doing an acidic medium in here, I want to stay away from the Cl attacking those hydrogens there and making an HCl acid. So this is why I'm going to use another base in the solution, which is the HSO4 minus, in order to pick up these two acidic hydrogens. So now we're going to go ahead and use a base in the solution. Okay, you don't have to be specific about the base, but here I'm just going to give you an example like HSO4 minus. As I said, I want to stay away from the Cl minus here. I could do a Cl minus, come and attack one of these hydrogens in there, and I'm going to end up getting an HCl. I'm just going to put it over here as a side note that avoid forming HCl acid since there is no pyridine to trap. Okay, so now my product in there, if I use any base in the solution, HSO4 minus, for example, that base is going to come, it's going to take the hydrogen, form a lone pair. I'm going to use it twice. Okay, so I'm going to go ahead and use it twice in there. I could have divided the steps. Here you go. And then I have an O hydrogen and the hydrogen with a positive charge. Then I'm going to use it again because it's there in the solution. So I can keep using it as long as I want to get rid of all the acidic hydrogens that I have. I could have divided my steps for the proton loss or the hydrogen loss. I could have used the base in this step over here to take that acidic hydrogen and then did resonance to kick out the chlorine and use the base again in order to take this hydrogen here. Or I can leave everything till the end and allow the base to attack as much as you need in order to get rid of all the acidic hydrogens in the solution. And your final product now is going to be a carboxylic acid. So what did I do over here? Take a look at your reactant. Your reactant had a chlorine in there next to the carbonyl. I replaced the chlorine by the OH. And that OH came from the water. We can do the same thing with the cyclic anhydrides. The mechanism can either go with a basic medium. So here I'm doing my basic medium. How did I know it's basic medium? Because here there is no acid. So if I'm just using water, then this is going to be a basic medium. Basic medium means that the water is going to attack the carbon of the carbonyl. This is partial positive. And it is reactive, so this is why it's partial positive enough for that weak nucleophile to attack, form a negative charge. The negative is going to close, and the O negative is going to leave. So here you go. Over here, we can do a proton transfer, make this an OH in there, and pretty much that's it. After we do a proton transfer from the base to the acid, the base takes the acidic hydrogen. I'm just going to go ahead and get my diacid in this case. That same reaction can happen also in acidic medium. So I can use water in presence of H plus. This is why I'm doing H3O plus in there. So water plus H plus, that is going to be H3O plus. So you can combine it like this, or you can leave it as water and H plus. First step is the protonation of the oxygen. So I'm going to end up having an H plus in there, protonating the oxygen as usual. Okay, so as usual, protonate the oxygen and then allow the nucleophile to attack. Be a very positive charge carbon. So this is a very positive charge carbon. So now the nucleophile can easily attack, break the double bond, add lone pairs to the oxygen there. Don't forget that every derivative of carboxylic acid that you start with needs to have a leaving group. So you are going up to a certain point to do a resonance and allow the leaving group to leave. It's this bond over here that is going to break. So you do resonance and the whole thing is going to leave. I'm not done yet. I know my product is a carboxylic acid, but I have too much hydrogens here. So I'm going to end up using any base in the solution. This is a base also because it's going to leave in the form of an O negative. So that is going to come take the hydrogen. I'm going to use another base, take the hydrogen. And that base is going to come take the hydrogen in there. So you're going to end up deprotonating it twice. Here you're going to lose a hydrogen there. So that you can end up getting your carboxylic acid. Let's do examples on saponification. Saponification happens with esters, water in presence of a basic medium. Now, the moment I see basic medium, then that's it. The base is going to immediately attack the carbonyl in this case, form a negative charge on the oxygen. This is going to be a good leaving group in basic medium. Remember when we said that oxygen in acidic medium should leave in the form of a positive charge. In basic medium, it should leave in the form of a lone pair. So since I have a basic medium in there, I can easily allow the OR to leave by resonance in there. And then if there is any extra hydrogen in the solution, that's going to be picked up by the base. Your product always follows the medium that you are working with. So if you are working with a base, a strong base, it doesn't make sense that you get the carboxylic acid. So here I have the acid, but my medium is the base. So what's going to happen is that any base in the solution will come and take that acidic hydrogen. You don't have to add an external base. We already have the OR that left, and that is basic on its own. So this one over here is a negative charge. It needs to stabilize by becoming a neutral. So this is why it's gonna come and take the acidic hydrogen, form a negative charge. So you are going to end up getting your product in there. That negative charge is gonna counterbalance whatever ion that is connected to the hydroxide. So if you have a sodium hydroxide here, then you're going to end up having the sodium salt. So let's have, here you go. This is going to be an ester, and we are hydrolyzing this in presence of an acidic medium. So my first step is going to be the protonation of the oxygen that is going to get protonated. And you are going to end up getting, this is a carbonyl, this is an O, here you go. So you protonated the oxygen in there. Once you protonated the oxygen, now water is ready to come and attack the partial positive carbon and open the bond. Okay. Again, we are going to keep saying this again. Your leaving group is going to follow the medium that you are working with. So I'm going to end up having an OH over here. I added water, and then I have my OR. Okay, now I know that this OR is going to leave at a certain point. So this is going to be my leaving a group in there. However, that leaving group cannot leave if it is in a form of a lone pair in acidic medium. What I need to do is I have to protonate that oxygen. So I have to introduce a positive charge on this oxygen for the O to be a good leaving a group in acidic medium. Okay, so in order to do this, I can do a simple proton transfer. So doing a proton transfer, I'm going to end up having my base taking this acidic hydrogen, forming a lone pair on the oxygen. Okay, so you're going to end up having your OH. Now you protonated the oxygen of the ester. Here you go. And I got rid of my extra hydrogen over here. So now we're going to go ahead and do resonance just to allow this good leaving the group to leave. So let's put this as a side note over here that this here now is a good leaving a group. And the reason why it is a good leaving group, because the O is positive and oxygen needs to be a positive charge to leave in acidic medium. In basic medium, it can leave in a lone pair form, but in acidic medium, it has to be protonated, having a plus a charge for it to leave. So I'm going to end up over here getting my, not yet my product though, because I still have a couple of steps in there to get rid of the extra hydrogen that I have. So here you go. I have that extra hydrogen, plus of course the alcohol that left. So the alcohol that left is ethanol in there. So now my last step is that I'm going to use a base in the solution. So the base can be HSO4 minus. So I'm going to end up getting my carboxylic acid in this case. It makes sense that I'm going to get a carboxylic acid. I'm going to regenerate the acid back. It needs to make sense. Your medium is acidic, so this is why your product is going to be an acid. If your medium is basic, like in the saponification, then you have to get the base of the acid. Pay attention.